Good day. You are welcome to my YouTube channel, created for digital designers like you. The goal is to promote and democratize digital design technologies by providing expert training and relevant industry exposures that will lead to enhanced project delivery and stimulate progress across a matrix of design disciplines. Revit Essential Training is first in a series of courses designed to achieve the set goal. In the previous lesson, we looked at AEC industry and digitization, Revit setup and user interface. In this chapter, we are looking at the anatomy of Revit. Before you embark on any Revit project, you should understand the nature and structure of the Revit so that you can work with it effectively. So we are going to look at Revit Elements Organizational Hierarchy, Revit Element Organizational Chart, and then Revit Element Properties and Revit Element Management. So under Revit Element Organizational Hierarchy, every Revit project you work on is a unique project on its own. It can be an architecture project, a landscape project, a structure project, a mechanical project, electrical project, and a plumbing project. Or it can be a combination of any of the two. So you can have an architecture and site or landscape project as one file. You can have a mechanical, electrical, and plumbing as another file. Or you can have a site and structure as another file. Or you can have site and mechanical as another file. So you can combine any of these files into one project, which it means that in effect, in any Revit project, you will need a minimum of 2 Revit files in order to be able to make the work complete. One Revit file will not be enough, as it will make work a bit difficult for you. So for instance, when we are working on an architecture project, it's advisable to separate one building project from another building project and then from the site model. So you can combine all of them into one project and work on them effectively, as to be illustrated as we move along. Now, if you take each project, the project is made up of categories of objects, and there are specific finite number of categories available in Revit. You cannot add to the list, you cannot subtract from the list. Each category of object is made up of families, and it can be 1 family, 2 families, 3 families, or any number of families that might be required for the project. And each project will require its own families that you can work with. If you take each family of objects, it can also be made up of several types. And each type of project can be used in the project at several instances of it. So for instance, you can have 1 instance of a door in a project, or you can have 3 instances of a tree in a project. Revit Element Organizational Structure. If you take any typical project, the project is organized around a category of objects. So we can have a category of objects, and within that category, we can have a family, and within that family, we can have a type. Then apart from the type, we can have several instances of that type, or an instance of that type. So, for instance, when I come to the green column here, we have one category of objects with one family within it. Within the family, you can have type 1 family, then you can have type 2 family. Then within the type 1 family, you can have 1 instance in the project. And within the type 2, you can have another instance in it, in that project. You can create another family within the same category of the object, like a new family member here, as noted in white. And within that family, you can create a new type, and you can create a new instance within the project. When I come to the one color-coded red, for instance, that in that category, there's only 1 family here. And there are 2 types, type 1 and then type 2. And then within the type 1, there can be 1 instance. But if you come to the type 2, there can be instance 1, instance 2, instance 3, and instance 4, which means that there can be 4 instances of the same object within the project. So you can create a new family within the project, create types under them, and then create new instances under them. When I come to the one coded blue here, you can also have 1 family here, type 1, type 2, and then type 3. Then within the type 1, you can have 3 instances. Within the type 2, you can have 2 instances of it. And within the type 3, you can just have 1 instance. then you can decide to add another family to the blue category again, so that you can create a new family and then create types and instances of it. If you want more categories within your project, then it means that you have to create another category, and the same way create families, types, and then instances as illustrated in the diagram. So for instance, if you take let's take a typical examples of organization of Revit. You can have, say, a wall, the walls category, and within the walls category there are three families: basic wall, stack wall, and then the curtain wall. So with the basic wall, you can create a type called brick wall. Then you can create another type called block wall. Then within the brick wall, you can create an instance of the brick wall within your project, or you can create several instances of the brick wall within your project. The same way with the block wall, you can create one instance of it or several instances of it within your project. The same thing is applicable to stack wall. The stack wall can be, say, a parapet wall, and that parapet wall, you can create several instances of it or just an instance of it. You can also get a curtain wall family within the wall family, and within the curtain wall, you can create another type of curtain wall called storefront curtain wall. And the storefront curtain wall, you can create an instance of it, or you can create several instances of it. The same thing is applicable to, say, windows also. So when we take windows, the windows too, you can have a rectangular fixed glass window. And a rectangular fixed glass window, you can have type 1 and then type 2. And the type 1 can be of a fixed dimension, say a fixed width and a fixed height. And then the type 2 can have another dimension of a different fixed width and a fixed height. Then you can create several instances of each of these rectangular fixed glass windows. The same thing is applicable to casement windows. So you can have a casement window family, and you can have different types of it. And within that particular type of it, you can create an instance of it or several instances of it within a project. You can also have a double panel sliding window. So the families of window slides can be long. So depending upon the project you are working on, will determine the family of windows you require. And for each family of window, you can have several types of it that you can use. And if you take each type, you can create several instances of it within a project. The same thing is applicable to ducts, pipes, and conduits. So you can have a rectangular duct, you can have PVC pipes, or you can even have conduits. And within the rectangular duct, you can have an insulated duct, or you can have a rectangular duct with a lining inside it. And for the insulated duct, you can create one instance of it, or you can create several instances of it. With the rectangular duct with a lining inside it, you can create one instance of it, or you can also create several instances of it. You can even create another rectangular duct as a family, which has both insulation and lining, depending upon the project requirements. You can also create PVC pipes, and then create a type of PVC pipe, and then you can create several instances of the PVC pipe of it. You can also create conduit families, and then you can create type 1 conduit family, and you can create several instances of it. You can create a rigid conduit family and create several instances of it, or you can even create a flexible conduit family and then create an instance or several instances of it. If you come to plumbing fixtures, for instance, you can have a shower family or showers family, and within the shower family, you can have type 1 shower, then you can have type 2 shower. The type 1 shower, you can have one instance of it or several instances of it. The type 2 shower, the same thing also, you can have one instance of it or several instances of it within one project. When it comes to WCs too, you can have WCs family, and you can have different types of WCs. So you can have type 1 WC, type 2 WC, type 3 WC. And with type 1 WC, you can have one instance of it, several instances of it. The same thing is applicable to sinks. When you go to the beam system, which is a structural component, you can have floor beam systems, then you can have roof beam systems. The floor beam systems, you can have type 1 with different elements, different configuration, different layout. Then you can have type 2 with also different element composition and layout. And you can create different instances of the type 1 and the different instances of the type 2 within the project. The same thing is applicable to roof beams. When you take a rebar, for instance, you can get a linear rebar family, then you can get a rectangular stirrups family, then you can get area enforcement family. With the linear rebar family, you can get type 1, which have different element properties, and then type 2 with a different element properties. And you can create several units of type 1 within the project and several units of type 2 within the project. For the rectangular stirrups too, you can create several types of it and then several instances within the project. And you can do the same thing for area reinforcement. So in effect, in every object that you are working with, you must know the category of object you are working with, the family the object belongs to. In the family too, you must know what type of object you are dealing with and how many instances you require of that object within your project. Note, there is a finite number of categories of objects. If you refer to the object type dialog box, you will see the list of all objects available to you, which we'll look at in the Revit setup very soon. The number of families and types can vary from project to project. So the kind of project you are working on will determine the families and types that you'll be working with. For instance, when you are working on a small residential project, you might need an A3 title block for your project. And the A3 title block, if you are doing a sketch design scheme, you might need an A3 sketch design title block. And when you are doing the working drawings, you might need an A3 working drawings title block. But when we are working on a complex project like, say, a hospital, the A3 title block might not be relevant for the hospital project. So you might need to create a custom A0 title block for the hospital project. Or you can even create a bigger sheet, depending upon the type of printer or plotter that you are using, just to fit the project needs that you require. And you can create several families of title blocks and several types of title blocks, depending on the project. Now, let's look at Revit Elements organizational chart. When we are working on Revit, we work with basically three main items: datum elements to establish relationships, content, objects that are repeated across projects, and views, legends, schedules, and sheets that are used for representation of your model. The datum elements is made up of three levels: references, levels, and grids. As a beginner, you must be very comfortable with working with references, working with levels, and then working with grids. Because if you are not able to work with these three items, then it will be very difficult for you to work with the remaining items also. The references can be a point reference, a line reference, or a plane reference. Point reference and plane references are usually used within the family editor to create family components. But in the point reference and line reference are used in the family editor to create family components. But the plane references are usually used within the project environment to work with them. Then we also have levels. The levels are basically horizontal references for the projects, and they can be used to generate your floor plans and your reflected ceiling plan views. All structural plans, all area plans are all generated based upon a level. Anytime a level is created, an artificial reference, an automatic reference is attached to the level that is created, and from that reference or from that level, you can generate your floor plan or your reflected ceiling plan. Then we have grids. Grids are used for structural organization of a project. So in the placement of your structural columns and beams and grids, a structural grid comes in very handy, which you can work with basically. Content. These are repetitive elements, and they are usually organized under 2 or 3 levels. Let me put it this way. We have the system content, then we have the loadable component or hosted component, the two of them. Now, the system contents or the system elements can either be a 2D system element or a 3D system element or a host element. The 2D system element is made up of text, lines, arrowheads, dimensions, field regions, details, revision clouds, match lines, and legend components. The 3D system host components are organized under architecture, structure, mechanical, electrical, and plumbing. Under the architecture, we can have walls, floors, roofs, ceilings, stairs, and then railings. For structure, we have foundations, walls, floors, beam systems, area reinforcement, path reinforcement, fabric areas, and fabric sheets. For mechanical, we have ducts and flex duct. Electrical, we have cable trays, conduits, and para conduits. For plumbing, we have pipes and then para pipes. Please note, all these system elements are usually sketched. So you use sketch tools like how to draw lines, how to draw polylines, how to draw polygons, how to draw irregular polygons and regular polygons to achieve some of these system elements. Loadable components. Loadable components are objects that you pick and load from an external file source and then use them. And they include annotation symbols and tags, detail components, and profiles. Profiles are a unique loadable component. They are neither annotation element nor are these a model system element. But they are very useful to enhance the design of system elements. We also have 3D loadable components for architecture. These are normally the 3D loadable components are hosted by other architecture objects, structural objects, mechanical objects, electrical objects, or plumbing objects. Before you bring in a 3D loadable object, there must be an existing object, which is a system object in the project, that will host the 3D loadable object that is coming in. So when we come into the architecture, we have wall-hosted loadable object. This includes a wall, a door, and a window, for instance. When there is a wall reference, then you can bring in a window that will be hosted by the wall. But when there is no wall, then there is no way you can place a window within a project. We have also a floor hosted objects. That is objects that are hosted by a floor, like say for instance furniture. We have roof hosted objects, elements that are hosted by a roof. For instance, roof gutter, roof fascia, and then maybe solar panels that are hosted by the roof. We also have ceiling hosted objects. Ceiling hosted objects include lighting fittings, air conditioning terminals, and so on. Then we have stair hosted object, and stair hosted object can be a stair nosing and then maybe a railing, because when there's a stair there, you can always host a railing on it. Then we also have railings hosted object. Railing hosted object include, let's say, a baluster. When you have a railings, then you can host a baluster within it. Without a railing, then you cannot put a baluster within the railing. If you go to the structure, we also have foundations. The structures have a special case. Although the beam might be a sketch, we normally sketch beams and we sketch trusses and we sketch braces and stuff, but you need to load them from an external source before you can use them in a project. Mechanical. Whenever you are drawing ducts, or whenever you are drawing ducting as a mechanical drawings, without an appropriate duct fittings, it will be very difficult for you to draw your duct. So the duct fittings and the duct accessories that is applied to your duct will determine the kind of duct that you are working with. So you can also load in air terminals, and then you can also load in mechanical equipment on your project. For electrical, we have electrical devices, lighting fixtures, electrical equipment, conduit fittings, and cable tray fittings. For plumbing, we also have piping fittings, piping accessories, plumbing fixtures, and plumbing equipment. Please take note of piping fittings and piping accessories, and conduit fittings and conduit cable tray fittings, and then duct fittings and duct accessories. They are very, very important. Without some of these things, work can be very difficult for you. Then we also have spaces and zones. Spaces and zones. Spaces and zones are space defining objects that are used by architects and engineers on the project that they are working on. For instance, a room, whenever a wall is, you define a 3 walls or 4 walls enclosed together, they define a room by which in use. They define a room in the architect's parlance, but the same a room can be used to calculate areas for that space, and you can even calculate the volume for that space. But when it gets to the mechanical engineers and the services engineers, they will refer to them as spaces and zones, and you can combine several spaces into zone and then work with them. Views, legends, schedules, and sheets. On any project that you are working on, you can work with a lot of views, or you work with a lot of views, which include 2D views, 3D views, schedules, legends, and sheets. The 2D views can be floor plans, reflected ceiling plans, structural plans, area plans, sections, elevations, detail call-out, and drafting views. The 3D views can be an orthographic 3D view, or it can be a perspective 3D view. We also have schedules. Whenever you are working on a project, you can also create schedules within the project, and it can be building component schedules, schedule keys, graphical column schedules, material takeoff, view list, sheet list, and note block. Legends. You can create legends for your annotations. Normally we call them annotation symbols legends, and you can also create legends for all the 3D components you are working with, called building component legends. Sheets. Whenever you are working on a project, you can also create a sheet view with a title block. So depending upon the kind of project you are working on will determine the number of sheets you will create and the kind of title block that you use on the project. Revit element properties. Anytime you are working on any Revit element, 2D or 3D, it has its own properties. And these properties can be arranged severally among this one: physical properties, graphical properties, thermal properties, appearance properties, construction properties, visibility properties, facing properties, identity properties, view properties, and sheet properties. Revit elements management and restrictions. Whenever you create Revit, you see we've listed a lot of things. You must know how to manage them and set restrictions on them so that they can behave in the way you want them to behave. This includes settings, location settings, facing settings, design option settings, groups, user interface settings, view template settings, work sets, and the work set can be system managed or user managed. I will stop here. If you have any question or if you have any further understanding that you want me to put clarity on, please let me know. In our next video, we will look at starting a new Revit project. Thank you very much for your attention. Bye-bye.